Hey guys, before I get into the solutions for your homework today, again, I just want to remind you that on Thursday, that will be your Unit 7 test. So anything that is on our study guide today and also on Wednesdays is going to be fair game, all right? Today during class, on Monday, we went through the odd problems. Again, use this video to check the even number solutions before you submit. Okay, and these, by the way, are the targets. These are all the things you're going to be tested on. Can you calculate scale factor? Do you know how to find the scale factor if I give you two images, right? That pre-image and that image. Or same thing, can you find that scale factor, but this time if I give you those images on a graph, can you visually go on there and count the side lengths and figure out your scale factor? Third thing on here is, can you perform the dilation, right? So not just find the scale factor, but if I give you the pre-image, right, and ask you to dilate from the origin, that is 0, 0. Do we know how to perform that dilation? This is where we use the coordinates. Do you also know how to dilate a set of coordinates given the scale factor? So not even graphing, right? Just kind of like number, very similar to this problem right here, performing the dilation, but not actually graphing it, just working with the coordinates. Can you apply a scale factor to a set of coordinates? Next thing on our list is, can you dilate from a given point? Okay, sometimes it won't be a dilation from the origin. Maybe it might be a specific point on the shape itself. Do you know how to dilate using the links? And then the last thing, do you know how to describe a transformation? All right, so again, if I give you the pre-image and the image, can you tell me, hey, they used a reflection, rotation, translation, dilation. What did they use to get from the pre-image to the image? So let's jump into the solution. So number one, we did that one together in class. Here's the solutions to problem number 2. It says rectangle A is a dilation of rectangle B. So please be careful, please be careful. Make sure you know which one's the pre-image and which one's the image. It says, what is the scale factor? So of course we are going to find the scale factor. Scale factor is equal to that new over the old, right? So your scale factor is new over old, right? So which one is the new one and which one is the old one then? Which one is the new one and which one is the old one? Oops, all right, technical difficulties, but I think we're back. All right, so yeah, which one is the new one? Which one is the old one? So it says rectangle A is a dilation. So rectangle A is a dilation. So that is going to be the new one, right? So this keyword here, that is the one that got dilated. So I'm going to label that one as my new. I'll go back over here to B and label that as my old. Okay, now that you have that, all you have to do is compare. Pick a side, compare. I'm going to go ahead and compare the top side of this new rectangle, which measures 6 units. So my scale factor here, not San Francisco, SF for scale factor, is equal to the new, right, which we said was 6. Now I got to compare it to the old one, but you want to compare it to the same side. I'm going to compare it to the top over here, which is 2. So I end up, my scale factor is 6 over 2. Obviously, we can do better than that. If you can divide, if you can simplify, please make sure you do so. I would prefer the fraction over the decimal. 6 divided by 2 does give us 3. All right, so our scale factor here is 3. And we can see that going from the old one to the new one. If you multiply by your scale factor, of not 2, of 3, if you multiply by your scale factor 3, 2 times 3 is 6. And if you compare that to any other sides, you'll see that it actually works out. If you compare the right to the right side, bottom to the bottom, it is a scale factor of 3. Okay, problem number 3 we did together in class. Problem number 4. It says, what is the scale factor that was used in the dilation, in the following dilation? So one more time, let's go through and find scale factor. That is the new over the old. Well, let's label which one's new, which one's old. How am I supposed to know that? Well, we can do that by looking at the letters that they use. There's D and then there's D prime. Remember, the one that has the prime, that is going to be the new one. So the smaller one down here is the new one. That means that the bigger one over here is the old one. So we should be getting a scale factor, because look, going from the old one to the new one, if you take a look at that, that's shrinking. We should get a scale factor that is between 0 and 1. So let's go through and actually find our scale factor here. Scale factor is equal to, pick a side on the new one. I'm going to go ahead and pick this top side from D prime to E prime. That measured 3. So I'm going to put a 3. over, and I'm going to compare it to the old one. Well, let me compare it to the old one from D to E. So I was using D prime to E prime. I better be using D to E. What is that distance up above? That's 1, 2, 3, 4, 5, 6. That was a distance of 6, or a length of 6 units. So there is my scale factor. It's 3 over 6, but we can do better than that. As I said earlier, whenever you can simplify, I do expect you guys to simplify. 3 over 6, I can divide top and bottom by 3. My scale factor is going to be 3 divided by 3 is 1. 6 divided by 3 is 2. My scale factor is 1 half. And it makes sense. If you take a look going from the old one to the new one, it pretty much got halved in its size, right? It's half its size. It makes sense that your scale factor is 1 over 2. We're basically taking all the dimensions, excuse me, and we're cutting them in half. All right, problem number 5 that was done together in class today. Problem number 6. It says, craft the dilation, the dilated image of a quadrilateral M and OP using a scale factor of 3 and the origin as the center of that dilation. So remember, when we are using the origin as the center of the dilation, right? The origin is 0, 0, the center of your graph. We're going to go ahead and use the coordinates. So you have to make sure that you're comfortable figuring out all these coordinates. So take a look at M. What were the coordinates for M? That was 1 to the right and then 3 up. So that's going to be 1, 3. All right. What about N? N is 3 to the right, 2 up. So that's going to be 3, 2. What about O? That is 2 to the right and negative 2 down. So 2, negative 2. And then lastly, P. That is negative 1 to the left. And then we stay at 0. We don't go up or down. So those were all the original coordinates, right? The original M, N, O, and P. So how do we figure out, how do we actually dilate using a scale factor of 3? So again, if I have to come back and use my scale factor of 3, what do I mean by use, by apply? All we're going to do is going to multiply all of our coordinates, all of our x and y values by 3. Everything's going to be growing by a factor of 3. So we're going to multiply all our x's and all our y's by 3. Go through and you multiply every single thing from your pre-image by 3. All of these coordinates by 3. And that should give us a new M prime, N prime, O prime, and P prime, which is going to let us graph. So M prime, what is that going to be? 3 times 1 is 3. And then 3 times 3, that was 9. So that's my new M prime. What about N prime? Well, 3 times 3 again is 9. 2 times 3 is 6. So N prime is N prime is 9, 6. What about O prime? That is going to give us 2 times 3 is 6. Negative 2 times 3 is negative 6. That is O prime, 6, negative 6. And then P prime. Negative 1 times 3 is negative 3. And then 0 times 3 is just going to give us 0. These should be the new coordinates. This should let me actually dilate my image, right? So let me start off with M prime. I go 3 to the right and then 9 up. 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way to the very top. That is M prime. What about N prime? Well, that's 9 to the right and then 6 up. 1, 2, 3, 4, 5, 6. Oof. Cutting it close at the very corners of my graph here. What about O prime? 6 to the right and then negative 6 down. 1, 2, 3, 4, 5, 6. That is O prime. Don't forget to put your primes on there and don't forget to label. And then lastly, P prime. That's negative 3 to the left, and we stay there at 0. That is going to be P prime. Okay, only thing we have to do now is just go ahead and connect our new image as best as we can. And there we have it. That is how you dilate. That is how you dilate from the origin, right? Take all the coordinates, the original coordinates, multiply them by your scale factor, right? And then go plot your new M prime, N prime, O prime, and P prime, whatever your new coordinates are. So that is the solution to number 6. That is how you dilate it. Okay, problem 7 we did in class. Problem 8. So this one says triangle ABC has vertices with the coordinates shown below. So they give us the coordinates, right? They give us the coordinates. So we don't have to go through and find them. It says if the triangle is dilated by a scale factor of 2 with the origin as the center of the dilation, what are the new coordinates? Well, remember, if we're ever dilating from the origin, okay, when we apply our scale factor, we just apply it to the original coordinates. So we're going to multiply everything here by our scale factor. Our scale factor was 2. We're just going to go through and multiply every single one of our coordinates, our A, our B, and our C, our original points. We're going to multiply them by that scale factor of 2. That should give us our new coordinates. That should give us our new A prime, which in this case, what's 5 times 2? That's 10. What is negative 6 times 2? That's negative 12. So there we have it. Those are the new coordinates of the image. What about B prime? Well, 4 times 2 is 8. Negative 7 times 2 is negative 14. And then lastly, C prime. What is negative 3 times 2? That's negative 6. And then 4 times 2, that is 8. So those are the new coordinates. You don't have to graph it. It was just asking what are the new set of coordinates, right? What are the new set of coordinates? So again, notice we don't even need a graph to be able to dilate from the origin. All you need to do is multiply by your scale factor. All right, problem number 9 we did in class. Problem 10. Here's the solution to problem 10. It says dilate the triangle using a scale factor of 2 and W as the center. So be careful. This time W is the center of the dilation. So this one is not going to change. That W is also going to end up being W prime. W and W prime are going to end up being the exact same thing. Everything else is either going to expand away or either shrink towards. Well, is it going to expand? Is it going to get bigger or smaller? Let's take a look at our scale factor. We have a scale factor of 2. So it means it should be getting bigger by twice its size. It should be expanding away from that W, from W prime. So whenever we're dilating from a specific point, like in this case W, you're going to be using the side lengths. So take a look at from W to V. This used to be a distance of 3 units. That's 1, 2, 3. Well, now we're going to apply our scale factor of 2. That means when you apply your scale factor of 2, you just multiply that by 2, and we get a total of 6. That distance that used to be 3 units, now it's going to get expanded not just to 1, 2, 3, 4, 5, but 6 spaces away. That is going to be your new V prime, right? Take a look at your new V prime. That is a distance of 1, 2, 3, 4, 5, 6 units away. I'm going to exaggerate it by highlighting it a little bit more, but there we have it. What about from W to X? Well, from W to X, that used to be just 1 unit. So if we apply our scale factor to that length, we multiply it by 2, we get 1 times 2, which is 2. So now instead of just being 1, it's now going to be a distance of 2. This is now where your new X prime is going to be. And again, this was W prime. Right, so there we have it. This would create our new triangle. That would create our new triangle, and we can see that, hey, our triangle's bigger, and W didn't change. W prime stayed in the exact same spot. Everything else, though, was getting stretched away from W. So that is our final answer there. That is how you dilate from a specific point. Okay, 11 we did in class. All right, so 12. It says use words like reflection, dilation, and translation when describing the following transformation. So again, which one's the new one? Which one's the old one? Let's take a look at that first. So I see that I have regular A and then A prime. So this should be the old one. Regular A prime should be the new one. So it's basically saying, hey, how did we get from here to here? Well, there's several things that you could have done. There's several combinations, right? So, and I could sit here and I could go through several different transformations. Here is one of the possible answers. You could have said that they translated. Remember, a translation, okay, that's shifting. Actually, let me review this. It's been a while. Translation, that is when you shift an image up, down, left, or right. That is what you call a translation. A reflection, that is when you flip over that imaginary line of symmetry. So you have a line of symmetry, and that's when you get flipped over, right? Reflected over either the Y or the X axis. And then the most recent one that we talked about, a dilation. That is when you enlarge or you shrink an image. So what can we say? What can we say? What can we say about this? We can say that, hey, from the old one, you would actually write this out. One thing you could say is to describe it, you can say the old one got translated, right? It got moved. If I can find a different color that stands out, and if it'll let me erase, apparently it will not let me erase. So you can say, hey, this was translated up. And then what else can we say? It was then reflected, right? Then it got reflected over the y-axis, right? It got flipped. So imagine that it was here and then it got reflected over the y-axis. But then that's not the last thing that they did. The last thing that they did was they dilated, they shrunk it down, they reduced it by specific factors. So that's what you can say to describe. You can say, oh, they translated it, they translated A up a couple units, they reflected it over the y-axis, and then they dilated it by a scale factor that reduced it. That would be how you would describe this transformation. Is that the only answer? No. No. Some students prefer to go this way. I mean, some students can say, well, you reflect over the y, so we would have ended up over here. And then you could have said, okay, now they reflected over the x, so we end up back up top. And then you could have said, okay, now they dilated to reduce it down to its smaller size. So again, there's more than one correct answer as long as you describe it using any combination of those three words. Do you have to use all of them? No, you can get away with just using two of those. You should be okay. So again, you should be okay as long as you're able to defend your answer. If I can follow your instructions and go from the old one to the new one, that would work.